Well, Brian's favorite pickup truck, Ram Tough. Problem? Well, I let go of the wheel and it wants to drift over to the right. When it's drifting to the right, I'm not talking about that 5-mile pull. I mean pulling off of 2 fingers to the right. Well, you guys been asking for suspension and alignment. I got the perfect truck to do just that today on Tech Garage. Well, welcome to Tech Garage, presented by RockAuto.com. Now, we get a lot of feedback throughout the year, and a lot of it's alignment angles, tire wear patterns, and suspension problems. But before you go out and get an alignment, we got some tips and tricks to save you some money, because there's a lot going on underneath that car. And you can actually take a look at this. There's a thing called a pre-alignment inspection, and there's 10 things you need to look at before you go get an alignment, or the alignment's not going to hold. So this will save you some money. Look at like a road test, tire pressures, chassis height. These are just all the basics. Check all the bushing, shock, steering. I mean, we'll look at all of that. But if you look down on the right here, it all starts with the tires and wheels. You know, our truck here, it's actually got a pull to the right. I wouldn't discount the tires and wheels before I go get an alignment. I want to take a look at it. That's what Brian's doing right now.
Well, that's exactly what we're doing. Look, I know it's counterintuitive. Typically, when you have a vehicle that pulls one way or the other, we head right to the alignment shop. We're talking about a root cause investigation, a full-blown root cause analysis so that you get the most of your alignment dollars. We do that by starting with a tire air pressure check. Remember, John was going down the road, it was pulling to the right, so I came to the right front wheel first. Easy to do, easy check. This truck calls for 40 pounds. That's exactly what we've got. If you're not sure, check the placard on your doorpost. It'll tell you what your PSI is supposed to be all the way around. That's good. So the next thing we want to check and rule out in the equation is tread depth. So you can use a fancy tread depth indicator like this, or frankly, you can use a penny. We've all done it in the driveway. And if Lincoln's head shows it's less than 3/32, then you've got a problem. We come around. We've got 6/30 seconds of tread here. So we're on our way to wearing out, but we're plenty of tread right now to do this test. So, next thing you need is a fancy roll of masking tape. The reason why, we're going to do a radial runout test. Now what that means is, don't forget there's steel belts all through this tire. If you hammer a pothole, there's an event, you run over a curb, those belts can get twisted up, moved, or even broken. And sometimes the evidence will be, in the radial runout test, you'll get hopping, you'll get cupping in that tire up here. This way, not this way. So we've got a dial indicator set up basically at 0. What we're looking for is no more than 60 thousandths of air as this tire tracks around. I'm slowly going to run it around. You watch that dial indicator, and we're nowhere near 60 thousandths being a problem. I like to run a few laps. And again, that masking tape ensures you've got a level surface to track. So next step is lateral run out. We're going to take the dial indicator, bring it up here to the sidewall of the tire, find a smooth spot, put it up against it, do the exact same test, look for the same type of error. At that point, we will have ruled out or ruled in that there's damage to this particular tire causing the pull. I'll get that done. Of course, I've checked for the hub assembly here. There's no play at 12 and 6, no play at 9 and 3. That all seems to be in order, but you want to see how this all really works? John's got the story.
Well, Brian's rolling along, but before we dig in too deep, let's take a look at a couple of tire wear patterns. So you can do this right out in the driveway and understand what's going on. You can see the first one up there. That's called feathering. It's actually scruffing the tires across. It's usually a toe problem with alignment. And then the other one on the right, that's actually one side wear. That would be a camber. We'll look at those angles a little bit later on how it relates to those tire wear patterns. Now, two easy ones, the overinflation and underinflation. Well, it's wearing in the middle or on both sides. And then the last one's cupping or chunking. You got some bad shocks in there, your tire's going to hop up and down and you're going to miss some pieces there. Now that pre-alignment inspection, that thing's key. So we can look at it right here. I got a parallelogram steering system here with a short long arm, and I have a McPherson strut. So look right up here. I would want to look at stuff like the upper bushings right here on the control arm. Why? Well, I said it doesn't pay to do an alignment if it's going to put down on the ground and then bam, move. So upper control arm. You have two ball joints here. You have a loaded and a following ball joint. That's huge too. If you go to the graphic one more time, you can see, depending on the spring location, if the spring's in the middle here, well, then you want to put the jack stand here because that makes this the loaded ball joint and the other one the follower. Now, if your spring's up on the top, that changes the whole ball game. You can see the other one. What I want to do is I want to jack up on the frame so I can unload the loaded ball joint, or I'm not going to be able to move it. So just get a big pry bar once it's unloaded, pick up, look for any movement. It's not rocket science. You come down here, you can see the sway bar links. I'm pulling, I'm tugging. You got the sway bar across. And then we get to the steering system. Well, dry park test. Put it on the ground, turn it to the right, turn it to the left. Look for any buckling in the steering system. It's going to move. You got a lot of weight on there. So when you turn, you see that buckling. That means the alignment's not going to hold. Don't waste your money. McPherson strut, same thing. Got a ball joint down there. You got your steering knuckle to check. One cool thing on a McPherson strut, though, it's bolted to the top of the car. And you actually have a plate right here. So if I turn the plate to the right, or to the left, you want to make sure that's all intact. Why? Well, this all affects the alignment. Caster, camber, toe. It has to be right. Well, speaking of alignment, we're actually going to hook up an alignment machine, and we're going to see what all those numbers actually mean. There's plenty more. Tech Garage, presented by rockauto.com, right after this break.
Tech Garage, presented by rockauto.com, is brought to you by Magic Creeper, the most versatile creeper ever. Borla, the world's most winning exhaust. And by rockauto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by rockauto.com. Now I'm dying to find out what's going on with our pickup truck. Brian, what did you find?
Chief, I went through every single thing on your checklist. I looked at sway bar connects and all anchor points. I looked at tie rod ends, the suspension loaded and unloaded. And of course, I finished the tire lateral runout tests on both sides. Everything was fine. So at this point, our truck is a good candidate for an alignment.
Boy, is it ever. And we brought out the big gun. We got the Hunter Hawkeye Elite system here, and it's super easy to use. I got the quick grip adapters on the wheels, moved it back and forth, man, in 10 seconds, 30 seconds, I don't know, it was so quick. Bam, I got alignment numbers up here, Brian. Now, we're not on an alignment rack, so it's not perfectly accurate, but boy, you couple this guy with a Hunter alignment rack, you're going to get perfection. Interesting. What do you think about those numbers?
It certainly is. I remember you crying about it, pulling to the right, going down the road. And right here at the right front tire, you can see that we're plus 0.8 on the camber. That absolutely would be a drivability symptom, as it would pull that way. Right? So I think this is potentially where we're going to make a repair.
Exactly. Well, what is camber? Well, look at the first graphic. It's the inward outward of the front wheels tilt as viewed from the front. So I'll tell you what, drop your coffee. This is the interactive time. This is when it gets fun. So we'll get our arms up there and we'll make them wheels. So if we go out like this is the positive camber, and then I go in is the negative camber. Well, think about it. It pulls to the most positive camber. Bingo. We got it. Pulling to the right. That's the problem.
Absolutely. And spec would be what? Plus 0.5 to minus 0.2, but we're clearly outside that boundary.
Yeah, 0.5 to positive 3 actually, but yeah, it'll fall right in there. Everything's going to be fine once we get it in there. But think about that tire wear too, man. We start getting out there positive. Yep. Bam, wearing the outside, yep. Negative, I'm wearing the inside. So yep. That makes a big difference.
Absolutely, we got to fix this.
Yeah, absolutely. Now another one, caster. Caster angles, well, kind of aids in steerability or returnability of the steering wheel. So once again, let's get our tires up. I'm going to go sideways this time. If we move the tires forward in the well and the spindle back, that's positive caster. Yep. Back here is negative caster. Now it aids in returnability of the steering wheel. Well, my chopper here, this thing has massively positive caster. So, you know, you let it go with the steering wheel and you can ride for hours, no problem, because you got good stability. Shop and buggy on the other hand,
yeah,
man, that thing's going down the road, yeah, and that's negative, so it wanders.
Absolutely.
That's two. It's not a tire wearing angle. We're not worried about it. Sometimes we use it for crown pull because we can cheat. Pulls to the least amount of caster, but not a tire wearing angle. Last one, toe, man. You know all about toe. You guys do that in the driveway.
Absolutely. You can set toe in the driveway, at least get it close enough to get a safe drive down to your alignment shop. You can take a measurement. You can use a yardstick, you can use a straight stick, any kind of a straight edge, or even a tape measure. And you want to get the distance from the front to the front, the same, the back to the back, as close to the same as you can make it in the driveway. Lots of times this is an issue after you're building a hot rod, some kind of a fun project, and you just have to get it close enough to get safely to the alignment shop.
Yeah, and you can look at the other graphic. It makes sense towed in. and then towed out. But we saw earlier that feather wear. Well, think about it. If that tire's towed out, not only are you dragging it along, you're scuffing it. So you get that feathered tire wear. This way, obviously, bad gas mileage, worst tire wearing angle there is, tow. That's going to do some damage.
Absolutely, and I'm going to hold this up one more time. I'm a cause and effect guy. I like to understand, why is this stuff happening? Why is it yesterday your vehicle was tracking down the road just fine, today it's pulling hard right? You got to think about events. Today's roads in America, the infrastructure is worse than it's been in a lot of years. So people aren't just hitting more potholes. What happens, I see people do this all the time. You're rolling down the road, here comes a big pothole, and you try to turn and miss it. But now, instead of a direct impact, a direct force and letting the tire work for you, you're adding all kinds of forces and side angles here to the blow, which can then lead to mechanical failure and wear of parts. And that's a cause that leads to that effect.
Yep, up to suspension. Think about the low profile tires. We're losing all that rubber in there and that cushion. Another thing we got to talk about, which is really cool, Hunter addresses it at the beginning of screens. They look at some of this autonomous stuff, Brian. People don't think about it, but the alignment is key when it comes to that autonomous stuff. I'm thinking like lane departure, okay? Imminent crash. Gosh, you got traction control, you got electronic steering control. All that, my friends, is depending on a steering wheel angle sensor. Absolutely. So if that car's not tracking quickly, that car's going down the road, if it's tracking to the left or tracking to the right, you're going to turn the wheels. Your steering angle sensor is going to be off. You may get a check engine light for one of these autonomous driving systems, or it may be unsafe to drive. So this is huge.
Absolutely, and that has impacted how true alignments, really good alignments, are done. That takes a lot of fancy equipment, just like our Hunter Engineering Hawkeye here. So it's really important to understand that alignment is no longer just about the attitude of the wheels and the tires. It's the autonomy system, right? It's amazing how much it all has come together.
Yeah, it really has. And you know what? We'll get this one fixed. We'll be pulling no more with our Ram pickup truck. It's going to be going, but more importantly, good gas mileage, no tire wear. That's important. Rolling smooth, man. That's what Hunter's all about. Well, I'll tell you what, it's time to head over to the LS engine build. We'll go ahead and hit that joker from now. Join us back. LS lesson is coming up next. More Tech Garage presented by rockauto.com right after this break. Welcome back to Tech Garage, presented by rockauto.com. Well, welcome to Project LS Lesson. Last week, we made a mechanical evaluation on the engine, and we determined its integrity. That's pretty good, so we know what we're doing. Now it's time for the teardown, Brian. But, Brian, I worked too long on flat rate as a technician, taking parts off, throwing them around. That's cool. I can do it fast, but later it's going to bite me. When I go to put this thing back together, not cool.
No, it certainly will. And here's a few tips for you. So you can grab an old silverware container and maybe even steal it from your wife's kitchen. I've been known to do that. The dishwasher can be your friend on a project like this. Most importantly, take notes. Copious notes. Use your phone. Use your document sheet. Take notes and really organize along the way. When I borrowed this silverware container, it's really good on a teardown to pre-label each bay. I also like to use Ziploc bags, keep the bolts all organized that way. Just really good tips. Now on the intake manifold, I started on the middle bolts and I've worked out because it's old and brittle.
And on fairness, you know, LS are pretty cut and dry, the bolts. I mean, you take off a coil pack like this, bam, look at it. You got everything intact. Don't take off the accessories if you don't have to. We don't know if we have a problem with any of them. That's a drivability problem, but look, everything's intact. I don't have another 100 bolts. My bolts are labeled right here, the coil packs. I like to do it in sections. I may do the right side of them. I may do the left side. I may have a bin for the front. I may have the bin for the back, and even a bin from underneath. I know what you're saying. Oh, that's crazy. Well, when you go to rebuild it, time is money, man. I start going down. I'm hunting for a bolt. I'm missing a bolt. Man, that's the worst thing in the world.
Absolutely. Well, I'm a little old school. I'm the guy in the garage who's taking my time and really not worrying too much about the flat rate, because I frankly can't wait to see what we're going to drop this into one day down the road and have a little fun with it. Because an LS, you can do just about anything you want to do with this thing.
Absolutely. Now this intake manifold, we're going to try to get this top end all taken apart. You know, we got to turn our attention to the front end when we start to get the mechanical, but these are all accessories, man. You may have map sensors up here. You may have throttle position sensors. You may have to remove the throttle body. That's why it's so important to organize, like Brian said. Ziploc baggies are great. These trays are great. Whatever you can do to get it done. Well, stick around. We're going to head into Garage Ed, man. We're going to get into those sensors now that we understand drivability a little bit. The sensors are interesting. We'll be back with more Tech Garage presented by rockauto.com.
Tech Garage, presented by RockAuto.com, is brought to you by Hunter Engineering, state-of-the-art wheel aligners and wheel alignment machines. Top Coat, the best coatings in the world. And by RockAuto.com, all the parts your car will ever need.
Well, it's time to put the pedal to the metal, literally, on Garage Ed this week. We're talking about throttle position sensors. Welcome back to Tech Garage, presented by RockAuto.com. Now, what is the throttle position sensor? What does it do? How does it work? And what happens if it's not working? Well, it's right here, and it does exactly what it says it does. It measures where the throttle is. I have one right here. It's bolted to it, and it goes through the throttle linkage. And when the throttle linkage goes up and down, well, it sweeps with it. That's pretty cool. And it's sending a voltage back. If you look at this first graphic here, well, there's a 5-volt reference going to it, and then there's a return you can see on that line there. Whatever comes back is what the computer determines where the throttle is, and you have a ground. At wide open throttle, we're going to be about 4.5 volts. Down at idle, we're going to be down about the 0.5 range. Now, the really cool part is I can actually show it to you in action. I got an oscilloscope hooked up here. So when I sweep it, you'll see the live electricity. This is really cool. So check this out. Brian Gregory, he got a new truck, and he drives pretty conservative, so I'm going to open the throttle real slow there. He likes to take care of his stuff. Creep to the top, you see the 5 volts, and I let it down. Now, if he gave me his truck, it would look more like this, man. Whammo, wide open throttle and closed throttle. Well, what does that mean? We'll take a look at this second graphic. Perhaps you're going down the road and that signal falls out for a second. Well, there's that little hiccup or that burp you may feel. The computer may not catch it, but that oscilloscope sure will. And it's also cool, we got it on the scan tool over there. So what is the computer looking at? Well, he can't feel it. He doesn't know what's going on, but he does know voltage. So look at the voltage over there. As I sweep it, bam, it goes up. I let it go. It goes down. And anywhere in between, he knows exactly where the throttle is. Once again, it's all about that precise fuel delivery. Now, Brian's over there dealing with a drive-by-wire. What's all that all about? Well, he's got an accelerator pedal position sensor and a throttle here. Now, the throttle's controlled electronically. I can push it and open it. That's what the computer would do. He'll open it up. How does he do that? Well, right here. You have your throttle position hardware out here, but you have an accelerator pedal position sensor up under the dash located on the pedal, no link. Kind of scary. You have no control over it. Don't worry. There's more fail-safe built into that than with the cable. Brian's checking it out right now. Let's check in with him.
Well, you're absolutely right, John, and this is a drive-by-wire system. Now, with everything out of the way here, you're getting a good look at the throttle body. I'll tell you what, technology and these moving pieces have come a long, long way and done a brilliant job in replacing the carburation process from years gone by. But a couple things matter here. Number one, the throttle plate itself. As you look inside the throat of the throttle body here, that home position of the plate is critical. It's critical for proper idle. It's critical so when you romp it to the floor, you're going to go somewhere. Not that John does that very often. But you've got to keep that clean so it's standing true. I'll show you how to do that in a second. You also want a good visual inspection of the connector. I like to put dielectric gel in there. It's a really good insulator. This is a very harsh environment up here. Just take care of everything. I'm going to put this back on. We'll come back to that. And let's look at the throttle plate. So in here, what happens is a lot of vehicles, if you tip this back with your finger or a tool to get access to clean the backside, you've destroyed the home position and it's got to be taken back to a dealer to get relearned. That's a big job. You don't want to tackle that. So do your homework and understand if that's going to happen on yours. So let me show you how to clean it. Very simple. Get throttle body cleaner. You've got to have the right stuff. The wrong stuff is going to damage components. Spray it in here and just wipe it down. Now, varnish and carbon build up over time, affecting that home position. Wipe it out. Another tool that works really well here is a toothbrush. You can get down around there. Now I'm going to tip this in and show you on the back side. I get it wet, saturated, and I'll take my rag and just work it up in there and see if I can find any varnish for you to come off. There you go. You got a little bit of dirt. All of that, believe it or not, makes a huge difference in the optimal balance of fuel and power for this type of application. All right, so this is good stuff. John and Tom, you got some more tech tips for us to make this job even easier.
Tom, today we talked about that drive-by-wire versus that cable. Now, as an old-school technician, the throttle position sensor was a little sensor. I see that whole unit. I'm thinking dealer item only.
No, it looks complex, but it's actually can be easier to install than like running a cable to an old carburetor or something. It can be a plug-and-play thing. And go to rockauto.com, you'll be surprised to see we not only have often the OE part, not at the crazy dealer prices. We'll have other manufacturers, often who have improved the parts, looking at what originally caused the OE part to fail. They made adjustments and used better connectors or whatever, and they last longer.
So we're looking at NTK, AC Delco, and standard. So I have the choice. I'm in control. I mean, one of them may be OEM, some may be an upgraded, a better model.
Right, and often the OE stuff here has been upgraded too. The original manufacturer looked and said, okay, well, this is why it failed, and their parts are upgraded also.
Perfect. So just go on there and check them out. You know, we're wide open throttle throughout this whole show. Let's check in with Brian. Whoa, Brian, I'm seeing green, man. You pulled it off. Another win here in Tech Garage.
I tell you what, just a few adjustments all the way around. All 4 corners of the vehicle are within spec. You can see the range. We're there. Feel really good about this, you know, especially the pre-alignment checklist. And so on a pickup truck, it's a big deal. You're towing heavy loads, you're hauling heavy loads. Big boy tires aren't cheap, so this was smart work today. I'm just going to hit print and get myself a spec sheet, and we're good.
Good idea. Yeah, you know, it's been a great day. We actually went to our systematic approach of a teardown on our LS build, man. We're going to keep going on that joker. It's going to be awesome. Now, Garage Ed, gotta love it, man. Accelerator pedal versus throttle position sensor, cool stuff going on. Kind of ties into the whole season. Unfortunately, we're out of time for today, but make sure you're back with us next week because we sure like having you here in Tech Garage, presented by rockauto.com.
Production assistance for Tech Garage is provided by Chipola College, located in Marianna, Florida. Founded in 1947, Chipola was recently ranked as one of the top 3 community colleges in the United States.